Welcome to this explainer. Today, we're jumping into two of the most critical signs you'll ever encounter in medicine, hypoxia and cyanosis. And look, these aren't just terms to memorize for an exam. They are the body's loudest alarm bells, screaming that the most fundamental system for life, the oxygen supply, is in big trouble.
So, let's start with the sight that will, get your heart racing. A patient turning blue. This isn't just some weird skin thing. It is a profound external sign that on the inside, the body cells are literally suffocating. It's a true medical emergency.
So here's our game plan for today. We're going to start with the invisible problem, that oxygen deficit happening deep in the tissues. Then we'll connect all the dots right up to what you actually see, and, most importantly, what you do at the bedside.
All right, first things first. We have to understand the core of the problem. Long before we see any of those dramatic outward signs, the trouble is already brewing deep inside the body, right down at the cellular level.
Okay, so this is absolutely crucial. Hypoxia isn't just about having low oxygen in your blood. It's about the tissues themselves being starved of the oxygen they need to make energy, to produce ATP. If there's no ATP, there's no cellular function. It is that simple and really that serious.
I love this diagram because it perfectly shows the entire journey oxygen takes. You really should think of it like a critical supply chain. It starts with the air we breathe, then it has to get into the lungs, cross into the blood, get picked up by hemoglobin, pumped around by the heart, all before it finally reaches the mitochondria where it's actually used. A breakdown at any, and I mean any point along this chain leads to hypoxia.
So let's dig into that. How exactly does this vital supply chain break down? Because understanding the why is the only way we're going to figure out the what to do next.
To keep it simple, let's stick with that delivery service idea. Imagine oxygen is a life-or-death package. Hypoxia is what happens when that delivery fails. So the clinical question is, where's the failure? Is it a problem back at the warehouse? Is the delivery truck broken down? Or did the package get to the front door, but nobody could open it?
And boom, here are the 4 major ways that delivery service can fail. With hypoxic hypoxia, the package, the oxygen, never even gets loaded properly. With anemic hypoxia, you don't have enough delivery trucks, meaning hemoglobin, to carry the load. With circulatory hypoxia, there's a massive traffic jam, like in heart failure, so the trucks can't get through. And then there's improper utilization, where the package arrives, but the cell can't open it, like in cyanide poisoning.
Okay, so we've talked about this invisible cellular crisis. Now, let's connect it to that dramatic, telltale sign we can actually see with our own 2 eyes.
This is it. This is the body's external signal that something is seriously wrong with oxygenation on the inside. It's literally the visual result of all that deoxygenated hemoglobin piling up in the tiny blood vessels right under the surface of the skin.
All right, if you're going to remember one number from this is it. It is a super high-yield number for your clinical practice. The key is that it's not about the percentage of saturation. It's the absolute amount of deoxygenated hemoglobin. As soon as you hit more than 5 grams per deciliter of it in the capillaries, that bluish color starts to show up. That's the magic number, the clinical threshold.
But wait, it's not that simple, is it? Not all blue is the same. Seeing the cyanosis is step 1, but being able to differentiate its type, well, that's the crucial next step in your diagnostic thinking.
Think of this table as your clinical cheat sheet. The huge difference comes down to the mechanism and where you see it. Central cyanosis means the blood leaving the heart is already blue. It's a systemic problem. You're going to see it in warm, well-perfused areas like the tongue. Peripheral cyanosis, on the other hand, means the blood left the heart perfectly red, but the limbs are pulling out so much oxygen, usually because of slow blood flow, that they turn blue. And that's why those extremities are also cold.
Okay, picture this. You've just walked into a room and you've identified cyanosis in your patient. Your mind starts racing, right? Let's take all that chaos and organize it into a clear, methodical approach.
Here is your 5-step mental checklist. First, you have to figure out the timing. Is this a lifelong thing or did it just start? Second, is it central or peripheral? Is the tongue blue? Are the hands warm or cold? Third, check for clubbing on the fingers, a classic sign of a chronic problem. Fourth, get some hard data with a blood gas. And finally, don't forget the zebras. Could this be an abnormal type of hemoglobin? Following this approach makes sure you don't miss anything critical.
So, we've walked through the fundamentals of hypoxia and cyanosis, but the real test, the real challenge, is applying it when things get weird.
So let me leave you with this. Think about a patient with cyanide poisoning. Their pulse oximeter might read a beautiful 100% saturation, but they are profoundly, dangerously hypoxic. How would you prove it? Think back to those 4 types we talked about. Which one is it, and how would you know? That's your next step.